Hello everyone. Today we are going to start first lesson of the syllabus, that is rotational dynamics. Now you all know what we are going to learn in this lesson. Rotational dynamics basically divided into two parts. In the first part we are going to learn about circular motion, and in the second part we are going to learn about rotational motion. Whenever we deal with motion like linear motion, then we need to define the terms like linear displacement, linear velocity, linear acceleration. Here also, in a circular motion, we need to define some terms like angular displacement, angular velocity, and angular acceleration. So, before proceeding with the actual concept, let's consider what is circular motion. Let's discuss what is circular motion first. Now we all know that from the 9th standard we have learned that if motion of object is restricted around the circumference of circle, then that motion we called as circular motion. Now suppose we have a circle traced on the ground and students are starting their motion from point A and they are moving along the circumference of circle. If R is the radius of circle with center O, then say any person running over the circumference is performing circular motion. Okay. Now when we deal with circular motion, say initially object was at point A. So the direction of that position from the point A to the point A can be indicated by vector OA. So vector OA I will call as radius vector. Now say object changes from point A to point B its position such that it describes certain angle, say very small angle it is describing, say delta theta. So this radius vector OA changes from OA to OB. So change in the radius vector, new position of radius vector. So I will say OA was initial position of radius vector and OB was what? Final position of radius vector. So during these two positions, object have described certain angle, and this term we called as an angular displacement. We called as what? Angular displacement. So what is angular displacement? Then angle traced by radius vector. Angle traced by radius vector during its change in the position is called as what? Angular displacement. Its SI unit is radian. Okay. Then say to cover this much of angle, that particle needed time delta t. Then the term which will be arises here will called angular velocity, and this we indicate by letter omega. So what is angular velocity? Then basic definition of velocity we know, that is rate of change of displacement. But here which type of displacement was there? Yes, here was angular displacement. So I would say rate of change of angular displacement is called as angular velocity, indicated by omega. It is given by d theta by dt, or in short omega equal to theta upon t. SI unit of omega is radian per second. If suppose particle further goes from point A to B and then again from B to C, so that its position vector is OC. During this it was traveling with angular velocity omega from B to C, so its angular velocity changes to omega 2, and for that it again takes time t. Then the term which arises there called as what? Angular acceleration. So angular acceleration can be given by formula alpha equal to d omega by dt, that is rate of change of angular velocity. SI unit will be radian per second square. Okay. Now from standard 11 we have learned that some relation, that is relation between linear velocity and angular velocity. Linear velocity and angular velocity. So that relation was given by v equal to r omega. In vector form we write this, vector v equal to omega cross r. Remember, everywhere in the circular motion, direction of angular displacement vector, like if suppose I am having a wheel of cycle and I am rotating it by placing cycle horizontal lying on the earth surface, and if I consider that axle is directed towards me, if wheel is rotating, then the direction of axle will be towards upward. So that direction can be found out by using right hand rule or right hand screw rule. So if suppose I am having a screw and if I want to put that screw into the wall, if suppose I am rotating that screw in the clockwise direction, then that screw will penetrate in. So motion of screw is circular motion and the displacement vector is going perpendicular to that circular motion. Therefore remember, in every circular motion, angular displacement vector is always perpendicular to the direction of radius vector. Okay. Now again we have some few things, that velocity equal to distance upon time. In one circular motion, in one complete circular part, distance travel will be equal to circumference and time will be period. So it is what? Circumference upon periodic time. So we have another formula, v equal to 2 pi r upon t, or 1 upon t is again frequency, so it will be 2 pi r n. So if I want to write this formula again, therefore we can get omega equal to 2v upon r. But what is the value of v? 2 pi r n upon r. So r will get cancelled, so that we will get omega equal to 2 pi n, or again you will get omega equal to 2 pi upon t, since period and frequency are reciprocal of each other. These all things you have learned in the 11th standard. Okay, this was just the basic things that what we have recalled to learn the lesson from the 12th standard. Okay, so let's learn the next part, that is type of circular motion. We have already learned that in the 11th standard there are two types of circular motion. First one is called uniform circular motion. Second one is called non-uniform circular motion. So what is uniform circular motion? If name is only suggesting, suppose I switch on the fan such that the regulator of fan is say at 4. I have set it at the fourth point, and now I have observed the fan after 2 minutes, and then again I have observed it after 4 minutes. So in between the gap of the 2 minutes, I found that the speed of fan was very constant throughout. Then I would call the motion of single or every particle on the blade of fan is what? Uniform circular motion. So how to define this? Then the circular motion with constant angular speed or constant linear speed is called uniform circular motion. Okay, now when we discuss the uniform circular motion, centripetal acceleration is required to perform uniform circular motion, and this centripetal acceleration is given by formula A equal to minus omega square r. Negative sign indicates that acceleration in a uniform circular motion and radius vector are oppositely directed. Negative sign indicates that the acceleration and radius vector are oppositely directed. Okay. When we discuss the uniform circular motion, two parameters should be important that are always to be discussed. The first parameter is the linear velocity. See, though it is uniform circular motion, but the direction of linear velocity changes. Direction of linear velocity changes at every point. For example, if this is the circular motion, object is performing circular motion in a clockwise direction. So here the direction of velocity will be like this, whereas here it will be like that, whereas here it may be like this. Though it is rotating with constant speed, but the direction of linear velocity changes with respect to time. Whereas the magnitude of linear velocity, magnitude remains same. Magnitude remains same. Okay. So what is uniform circular motion? The circular motion with constant angular speed or linear speed is called as a uniform circular motion. The centripetal acceleration is acts in the uniform circular motion whose magnitude is given by A equal to minus omega square r. This derivation you already have learned in the 11th standard. So just recall from that 11th standard. Negative sign here in this formula indicates that there is acceleration and radius vector oppositely directed. In the uniform circular motion, linear velocity, in which direction of linear velocity changes with respect to time and magnitude of that linear velocity remains constant. Okay. Now let's discuss non-uniform circular motion. So what is going to happen in a non-uniform circular motion? Now suppose in the same previous example, suppose the blades of fan are such that I am rotating the regulator of fan continuously from 1 to 3, 3 to 1, 3 to 4, then 5. Like that I am continuously changing the knob of the regulator. Then what is going to happen? The blades of fan will rotate but with variable speed. Are you getting that? So the circular motion in which variable linear speed or angular speed is called as what? Non-uniform circular motion. Because of its continuous variations in the speed and angular speed and linear speed, corresponding angular velocity and linear velocity also changes. And so that if I say, if object is performing non-uniform circular motion from A to B, its velocity is changing. Its velocity at point A was say V1 and at point B is say what? V2. So since the velocity is changing, corresponding acceleration also is changing. So total acceleration acting on the object is divided into two parts. The first part is called tangential component of acceleration. The first part is called as what? Tangential component of acceleration, and the second part is called radial component of acceleration. Now the component of acceleration towards the direction of velocity is called a tangential component, and the component of acceleration towards the radius is called a radial component. These components are always perpendicular. If this is the center, this will be the first component, this will be the second component, so that this will be the resultant acceleration. So it may be AR vector, it may be AT vector, so this will be the resultant vector A. Okay, the value for acceleration then given by vector AT plus vector AR in magnitude. If I want to find out magnitude of vector A, then it can be given by AT square plus AR square. So during non-uniform circular motion, the acceleration acting on the object is divided into two parts. The first component is called a tangential component. It is either along the direction of velocity or opposite to the direction of velocity. The second component is radial component, that is always towards the direction of center of the circle. In that case, the magnitude of acceleration can be given by this formula. Now, here, if suppose speed of object is increasing, if the speed of object is increasing, then the particles will also perform the same motion as the angular direction, and as the velocity of angular motion will be there. In that case, we will say the angular direction, angular velocity vector and the angular acceleration vector both will be directed along the same line. So for increasing speed, omega vector and alpha vector are along same line. Remember, and for decreasing speed, omega vector and alpha vector are along opposite direction. Okay, so this was what? Non-uniform circular motion. Remember, in a uniform circular motion, speed of object is going to be constant, whereas in a non-uniform circular motion, linear as well as angular speed is going to change. Because of that, the acceleration in the non-uniform circular motion is resolved into two components, whereas centripetal acceleration is enough to produce uniform circular motion. I hope you understood this article. Thanks for watching mahasarkar.co.in. Thank you.